So what we just talked about real quickly was corresponding angles, and the class named all the other pairs of corresponding angles. Are there any more same-side interiors? 3 and 6 are listed. Is that it?
4 and 5.
4 and 5. Good. Any other alternate interior? We have 3 and 5. Any others?
4 and 6.
4 and 6. Any other alternate exterior?
1 and 7.
1 and 7.
2 and 8.
Okay. Now, one thing that's not on here is a linear pair. And when we think about a linear pair, that's when we have two angles, and I should have written the word 2 here, that share a common side and form a line when you put them together. You see this? This is a linear pair. So angles that form a linear pair must be supplementary because they form that line, and the line is how many degrees?
180.
180. So just reminding you, you may not have had, did any of you know the term linear pair before you came in?
I thought they were called
Okay. Okay. So those of you that didn't know it, you might want to add this to the notes there.
You don't even know what a linear pair is now. He's still. Tell me right now. Tell me. Oh, see, now he's looking. Wow. Not a right-handed. Right-handed.
They call them adjacent
Okay.
angles.
So if we have same side interior angles postulate, it says if two parallel lines are cut by a transversal, then the same side interior angles are supplementary. Now, this is something you learned last year, right? And you learned this last year, right? Two parallel lines cut by a transversal?
Yeah.
Yes. So we know that same side interior is supplementary. Supplementary means their sum
Equals
is
180.
180. So if they gave us that angle 6 is 61 degrees, how can you find the measure of angle 3? Well, these are same side interior, so we know, therefore it'd be supplementary. So the measure of angle 3 would be 180 minus 61, which is
119.
119 degrees. Now, with this one angle measure, we can find all other angle measures, can't we?
Yes, ma'am.
Because if this is 61, we just found that this was 119. Well, if this is 119, then angle 1 is also 119 because they are vertical angles, right? And then these are corresponding, so if this is 119, what is 5?
119.
119. Or we could have said that 5 and 6 form a linear pair and done it that way. Okay, 4 and 6 are alternate interior, so if this is 61, this has to be 61. 2 and 6 are corresponding, so this would be 61. Or we could have said, ooh, vertical. And then 2 and 8 are alternate exterior, so it would have to be 61.
And the other one's
7,
119.
119.
And then 119.
That's too easy.
Okay, so with one angle, we can find all the missing ones. And we'll end up doing some puzzles. They're really, I like them. They're like angle puzzles. We'll do some of those. Okay, let's flip over and look at the proof. Okay, so what are we trying to do? What is our goal here? So if two parallel lines are cut by transversal, then pairs of alternate interior angles have the same measure. So that's kind of what we're justifying here. So are 3 and 5 alternate interior?
Yes.
And we're showing that they have the same measure. So this is our goal by this proof. And we're starting with the fact that P is parallel to Q, and that is given. Do you guys see how the reasons are right up here?
I like that a lot.
Makes it really nice, doesn't it?
I wish we had that on our test.
Okay, 3 and 6 are supplementary. How do we know that 3 and 6 are supplementary? Because they are same side interior angles. So same side interior angles are supplementary. That's what that postulate says, right? So if they're supplementary, then their sum is 180. Why is that? Definition of supplementary angles.
Nice.
Okay, 5 and 6 are a linear pair. Now, this is given in our picture, isn't it? And it doesn't even matter if this picture is not drawn to scale. They still form a line. So even if it's not drawn to scale, doesn't that have to be true?
Yes.
And it was given in the picture. And we'll go given picture. Okay, so since they are a linear pair, then we know they are supplementary. Why? Linear pair theorem.
Yes, we just learned about that.
Yeah. Okay.
I remember.
So since they're supplementary, they must add up to
180.
180. That is the definition of.
Supplementary angles.
Defi of sucky angles.
No,
Supple.
Dude, swag.
Does that work?
No, that doesn't work.
No, I'm talking about supple. It's like
I heard you, and I said no, that doesn't work.
What did
You
Roman
said
say?
something, and I was like, well, supple.
Okay.
Half hog.
This equals 180, and this equals 180. So since they both equal 180, can I substitute this in right here? Because this is 180 and this is 180. So this would be substitution.
I have a question.
Yes. Go ahead.
On the angles, when you draw like a little, angle, why is there a line through it sometimes and sometimes there's not?
I don't know why I do that.
Yeah, you just kind of like.
Does it matter? Okay.
All right. And the measure of angle 3 equals the measure of angle 5. What needs to go on this one to make this happen?
Wait, don't.
Given.
No one answered. It's the.
They beat you to it. Subtraction property of equality.
Nice.
I was so close.
Got it? Okay.
Are you alright, Miss Goldie?
I'm feeling a little tired.
So am I. I always feel tired.
Okay.
Yes.
Let's take a look at this one. Flip over to 3.
¿Dónde estás, kids, babe?
Alright, so let's look at what we're trying to prove right here, guys. If two parallel lines are cut by a transversal, then pairs of corresponding angles have the same sum. So this is what we're after. How are we going to show that? We're showing that 1, not have the same sum, have the same measure. 1 and 5 are corresponding, and we're showing they're equal. That's how we're showing this. So we're starting with this, which is given. And because we know they're parallel, then we know that angle 3 is equal to angle 5, y. Alternate interior angles are congruent. Oh, I used the congruent symbol, not the words. Okay, and we know that 1 is equal to 3 because why? Vertical angles. Good. Vertical angles are congruent. Okay. So if 3 equals 5 and 1 equals 3, if we switch these two and said if 1 equals 3 and 3 equals 5, ooh, that would have been better.
That's transitive.
Then 1 equals 5.
That's transitive.
Okay, so we can do substitution or transitive.
I know transitive because that's what I said. I'm not smart. Transitive property. Holy cow.
Usually when we use transitive, they've given them to us in the right order to start with. So 3 would really need to come before 2. But I'm with you. Sounds good. All right, now we're going to talk about this little part right here. So we're on page 49 in your workbook. What?
Mine doesn't have smiley face. Who cares?
I put those on there.
Oh, okay.
They made me happy.
Yeah. They made
All right, so here it says many postulates or theorems are written in the if P then Q form, with if the hypothesis part, then the conclusion part, right? So, like if two parallel lines are cut by a transversal, then alternate interior angles are congruent, okay? So, the converse of one of these statements is where we switch it. If Q, then P. Now, a converse of a postular theorem may or may not be true. May or may not be true. So, if my daughter cleans her room, then she'll get her allowance.
You give her kids allowance?
If she got allowance, then she cleaned her room. Not necessarily, because her allowance is based on many things.
I don't get
about doing
All parents choose different methods.
Yes.
We choose an allowance and then tell our children no a lot and say use your own money.
I asked
Yeah,
my
but
son
sometimes if you don't
So-
get an allowance, they feel obligated to give you money when you go places.
Huh.
That's why
No, my parents just make you work.
There you go.
I work in the factory.
I'm actually going to start doing mine when my kids get in high school.
Yeah, your kids won't like it. I don't like it. I'd rather just get $20 when I go out to eat.
Yeah, I don't get allowance.
All
right.
I pay to do stuff around the house. Like if I mow the lawn, I get money
I only
back.
get
Okay, so maybe the allowance example took us on a tangent. So let's come back now.
Speaking of allowance,
So these three do hold true. So if same side interior angles are supplementary, then the lines cut by the transversal are parallel. If alternate interior angles are congruent, then the two lines are parallel. If corresponding angles are congruent, then the two lines are parallel. Okay? So these are true. Not all of them are, but the converse for these three are true. And we're going to use them to prove parallel lines. So if you can show me that alternate interior angles are congruent, then you can prove parallel, right? If you can show corresponding angles are congruent, then we can prove parallel. This one's important because we used it when you did the construction of parallel lines, didn't you? You created congruent corresponding angles. Did you realize you were doing that? That's exactly what you were doing. All right, so let's look at these real quick on page 53. Okay, the given angle measure is 133 degrees. And do you see it showing parallel? So this angle and this angle, how would you classify them?
alternate
Same side?
side.
And so they would be supplementary, so angle 1 would be what?
133 degrees.
47. 133 minus 180 minus 133. Okay, look at these two. Angle 2 and the given angle are, how would you classify them?
Same side.
Corresponding.
Corresponding.
Boo!
This was same side. This is corresponding. And corresponding are congruent, so this would be 119. Okay, how would you classify X and 83? Ooh, we can't, can we?
no, if you believe.
No. But this is corresponding to this, and then these two form a linear pair, don't they? So if this is 83, then this would have to be 97. Okay? How would you classify these two angles on number 4?
They're the same.
Alternate interior. So they are the same. So what would we do to solve this?
Set them equal to each other.
Set them equal to each other? So we'd get 8x plus 34. Or is that minus? That's minus. Sorry. Minus 34 is equal to 5x plus 2. So 3x equals 36. And x equals 12. I'm done.
No.
No, I'm not. Because then you have to plug it in to find out what angle DEF is. DEF is this one. Well, since they're the same, it doesn't really matter which one we plug it into.
It's 60.
So 60 plus 2 is 62.
I got it before you told me.
Good. Any questions? All right. If we have time, we'll come back to some of those. Now, what I want to do is I want to practice the parallel line construction. So, what we did was you had a point off the circle, and the first thing you do is draw a line through it. Okay, let me do this a little better. All right, here we go. Where's my line tool? There it is. I'll give it a try. Oh, that's amazing. All right, then we take the compass, and you should be impressed. Whoops, not yet. Don't be impressed yet. Okay, take the compass, and we're going to come here, and we're going to draw an arc.
Whoa.
And then I'm going to move it up to here. Here it goes. I'm going to move it up to here, and I'm going to draw the same arc without changing my compass. Whoops. I didn't draw a good arc here. I went loop-de-loo. Oh. Uh-oh. Oh, no. This is terrible. It's terrible. Whose fault is it?
Yours.
Matt.
What the?
Okay, let me reorient myself to where I'm not looking at it sideways.
I'll punch Matt for you. He deserves it.
Okay, you know this is recording, right?
Really?
So
Awesome. I'm ready to go hear myself.
when Matt says Kyle's bullying me, and
You're
then
not friends, though.
the administrator says, all right, here we go.
I said I'll punch him for you. I didn't say I was going to punch you just because.
Okay, here we go. I can do it now. All right. So, I really wish. There we go. There we go. Now I got it in a good position. So now we're just going to arc, and then we'll move it up here, and we're gonna arc it again. All right, double arc. Okay. Then what you do is you take it and you put it here.
Okay, babe.
And then you measure to here. How far is it from here to here?
29.
And I'm going to change colors. And then we're going to arc it. Oh, I missed. That wasn't all done. Okay, there, I got it that time. And then we're going to slide it up to this one. And then we're going to arc it.
Oh, Evan, that's what happened to us.
Yeah.
Oh, you know why? Because I put it in the wrong spot. Now we're going to arc it. Okay? And then we can draw the line through the point and it should be parallel to the base. Mine's way off. Okay, so I did a really good one right here. It's hard to use the overhead, but I did the same thing here. So you drew the line through, you did an arc. Then you measure from here to here, arc, from here to here, arc, draw the red line through both. Okay? So flip over to page 57. 57 ought to be an easy one to do for you, because the book should be flat.
Yay.
And I want you to try to draw the parallel line on 1 and 2.
We're supposed to get these earlier.
Is our homework in our workbook?
Your homework is out of your textbook, and it is posted on the website.
Right?